Problem 6. What is the minimum ampacity of a branch circuit conductor for continuous rated? So continuous rated motor, but it's used in what? Varying duty application. So it's not used in a continuous duty application. Did we have anything that addressed non-continuous applications? All right. So we're still at 430.22. But the part that we've been using, 430.22 for a single motor, it says it's a continuous duty application. Do you see that? So, okay, we're going to look at A, direct current, B, multi-speed, C, Y delta, D, part winding, E, other than continuous duty. You guys there? All right. Conductors for motor used in short time, intermittent, periodic, or varying. Oh, that's what's in the question, right? Varying duty applications have an ampacity not less than the percentage of motor nameplate current shown in table 430.22e. All right, let's look at table 430.22e. Okay. Let's go across the top where it has the motor types, right? This is a continuous rated motor. You see that? So we go over to continuous rated motor. I'm going to read down to varying duty. What's the percentage given there? 200%. 200% of what? Go to the top of the table. See, nameplate current. Do you see that? All right. 16.5. I'm going to say 33. Now I would.
That has to do with what the motor is rated for and the application of the motor.
Yeah, it has. Yes, both of those. The motor's not being used in an application where it's got a consistent load. The load is changing wildly, right? Well, maybe not wildly, but it's varying. You guys see that? So on that table, maybe a good highlight would be to highlight nameplate. Make sure you see that in there. Okay. So great. We said we need 33 amp wire. The next problem says, okay, what size wire are you going to use?
Number 8.
.16. Table 310.16. In this case, they did give us a 75-degree rated wire too. Make it a little bit less confusing. It's what?
You could get by with 10.
Number 10.
Pins are rated at 35. Yeah.
All right. Anybody have an issue with using number 10s here?
Well, it's like it feels like it's ingrained in everybody's brain that 10s are good for 30 and 12s are good for 20 and 14s are good.
Why is that ingrained in your brain?
Because you get the D rate for current carrying conductors.
That's not why it's ingrained in your head.
I forget the reason to get it.
Okay, go to table 310.16. Okay, are you at the table? Look at 18, 16, 14, and 12 gauge wires. Do you see anything special about those sizes? They've got a little asterisk beside them, right? Let's go down to the asterisk down at the bottom of the page. Okay, let's look at 240.4D.
Number 7, 10 AWG copper, 30 amps.
Okay, you guys see that? All right, what's number 12? 20 amps, right? You go to 31016 is number 12, a 20 amp wire.
No, it's 30. Not in the.
No, in the 75 degree column it's 25, right?
Yeah.
We use it on a 20, why? Small conductor rules, right? These are referred to as small conductor
that's
rules.
the only rule? I thought there was something else. I
Right?
just remember, I don't know, something deep in the depths is telling me that we learned it some other way, but probably not.
Small conductor rules. Now you do have to derate the wires too. We're not covering that today, but that's the small conductor rules. Now my question is, does 240.4 D 1 through 7 apply to motors?
No, motors has their own rules.
Motors has their own rules. We read that earlier, right? Table 240.4G and 240.4 said, so right? So, hey, 240 doesn't apply to overcurrent protection for motors unless 430 references something there. So, small conductor rule, gone.
So, you could use tens.
I could use 10s.
Would you use them? Depending
Sure.
Depending on.
Probably depending on the distance that the circuit's running, right? Yeah. Yeah. Because look, what is the, and this is why I say I wouldn't have a problem using 10s. What is the motor actually drawing? 16 and a half amps. You see that? Do you feel more comfortable with the number 10s? Yeah.
The only reason you're sizing it for
That varying duty that's happening, right? That varying duty that's happening is probably throwing that motor into frequent overloads, which is running this amperage up.